Hello students, let's continue the examples on Karl Pearson's coefficient of correlation. Example, find the number of pairs of observations from the data. What was the data given to us? R is 0.5, summation x minus x bar into y is 120, sigma y is 8, and summation x minus x bar square is what? 90. This is given to us. So, solution, given R is equal to 0.5, summation x minus x bar into y is 120, sigma y is 8, and summation x minus x bar square equal to what? 90. What is asked to find? We have to find n is how much, right? So now as we have, using Karl Pearson's coefficient of correlation, R between x and y is covariance between x and y upon sigma x into sigma y. That is same as 1 upon n summation x minus x bar into y minus y bar upon, this is square root 1 upon n summation x minus x bar square, and this is 1 upon n summation y minus y bar square. This is a result. Okay, so what is here with us? This R with us, that is 0.5. N is unknown, so keep it as it is, 1 upon n. This sum with us, this sum is same one, is given to us, that is 120. Some part will become 0 in that product, that's why this is given to us. Now here root, what? 1 upon n, this sum is given, that is what? 90. And here this answer, that is sigma y, is given to us. It is how much? 8. This is in square root only. This 8 is not in a square root, remember. So now this can be written as what? This 120 upon this n, let me take a denominator with this 8n. This can be written as root 90 upon root n. This is in a square root. So this n and this is square root n. So that is 120 upon 8 into square root 90 into what? Square root n. This one of the square root is get cancelled. Now let me take this square root n to this side, or let me put this 0.5 is what? Half is 120 upon 8 into square root 90 into square root n. This is same as square root n is equal to 240 upon 8 into what? Square root 90. This one gives us. Then this is square root n is equal to 3.16227. Square root n is this, so by taking square on both sides, n we get 10. It is, these are number of observations, so I will got it as 10. You can check that one. Fine. Now let's go for the next example. given that R is equal to 0.6030, summation x minus x bar y minus y bar is 24. Summation y minus y bar square is 44. Sigma x square is 4.5. Find number of pairs of observation. Same type of question, then we have to find, but the given data is somehow different. Okay, solution. R is coefficient of correlation. This is covariance between x and y upon what? Sigma x into sigma y. So this is same as 1 upon n summation x minus x bar y minus y bar upon square root or into sigma x. I can write in a square root of sigma x square, and this is sigma y is, it is in a square root 1 upon n summation y minus y bar square. Okay, so this is 1 upon n as it is. What is r with us? Sorry, 0.6030. Left hand side we should write first. Now 1 upon n, what is this sum is given? 24 upon, this is sigma x square is 4.5 into 1 upon n, what is this? 44. So again, just like a previous part, this will become 0.6030 equal to, this is 24 upon what? 24 upon square root n into square root 4.5 into square root what? 44. This. Now that is same as square root n equal to 24 upon 0.6030 into square root 44.5 into square root what? 44. This is a denominator as it is. So we get square root n, simplifying it, we get it is 2.8285. Therefore n is how much? N will be 8. Now here let me give one example of this kind as a homework to you for finding n. Homework. For a bivariate data, R is equal to 0.4 summation x minus x bar y minus y bar, this product is 108, sum of product. Sigma y is 3, sigma summation x minus x bar square, this is 900. Question is that find number of pairs of observation. Number of pairs of observations. Find out this. This is a homework for you. And let me tell you answer. The answer for this, you must get n is equal to how much? 9. Okay. Now let's go for the next part, coefficient of determination. Coefficient of determination. What does this exactly? A very useful and convenient way of interpreting the value of coefficient of correlation. The value of coefficient of correlation between two variables is to use square of coefficient of correlation. Square of coefficient of correlation is a very useful thing or the convenient way to use, and that square of coefficient of correlation is known as coefficient of determination, which is called the coefficient of determination. Coefficient of determination, that is, in a simple way I can say it is r square. R is coefficient of correlation, r square is coefficient of determination. The coefficient of determination that is what r square is defined as the ratio of the explained variance to the total variance. To the total variance. Therefore, coefficient of determination equal to r square, and that is equal to explained variance upon total variance. Okay. If r is equal to 0.9, that gives r square is what? 0.81, right? Therefore, we can say 81% of the variation, 81% of the variation in the dependent variable has been explained by the independent variable. This is the meaning of it. Now let me give few notes on it. Note first, r square is always lies between, obviously, 0 to 1. Lies between 0 and 1, we can say 0 and 1. Second, r square is always positive. square is it? Always positive. Third, it cannot tell whether the relationship between the two variables is positive or negative. It cannot tell us about it, positive or negative. This is a demerit, you can say, of it. Okay, now let me take one small example for this. If correlation coefficient between x and y is 0.83, what percentage of total variation remains unexplained by the regression equation. Okay, this is a question. Solution for this, a very easy thing. R is equal to what? 0.83 with us, right? This is given. Now from this unexplained variation is what? 1 minus r square. 1 minus r square, we get it is 0.3111. Therefore, percentage of unexplained variation is how much? 31.11, right, percent. This is our answer here. So now here this is about coefficient of determination. Now further we have to see Spearsman's rank correlation. Let's go towards that. Spearsman's rank correlation. Another approach for determining the degree of correlation between two variables is this Spearsman's rank correlation, and that is based upon the ranks of the values in each variable. The coefficient that is determined from these ranks is known as rank correlation coefficient. Rank correlation is a technique for measuring strength of relationship between paired observations of two variables. When the data is in ranked form, a rank correlation R is given by R equal to covariance between x and y upon sigma x into sigma y, or it is 1 minus 6 times. This is 6. Remember, this is a number. Summation di square upon n into n square minus 1, where this di is what? Difference xi minus yi. N is number of pairs of observation. Pairs of observations. Okay. Note that just like a correlation coefficient, this R also ranges between or lies between -1 and 1. So here we will stop. Next video we will see examples on this one, and also we will see Spearsman rank correlation for if ties are there. Ties are there. Okay, the slight change in the result for that. So we will see that one also with example. Thank you.